We want to take a look in this video at the general concept of volume. So we've taken a look at area, but we want to take a look now at volume. And the volume is the amount of space that an object takes up. If we look at just a simple box here, a simple box, the volume is the amount of stuff that you can put inside. Volume is always measured in cubic units. Again, we have three dimensions here. We have a length, we have a width, and we have a height. And we're just going to look at these sort of boxes to try to find the volume. And so let's say we have a length of 14 inches and a width of 10 inches and a height of 8 inches. So this could be the height as well. Well, we know that if we have all of our units the same and they're all measured in inches, then volume is equal to length times width times height. So volume is equal to length, which is 14, times width, which is 10, times the height, which is 8. And we can go ahead and do our math. It's really easy to multiply this 14 times 10, because 14 times 10, we just have to slide the decimal place over 1. So 14 times 10 is equal to 140. And now 140 times 8 will give us 8 times 0 is 0. 4 times 8 is 32. So we write down the 2 and carry the 3. And 1 times 8 is 8, plus the 3 we carried gives us 1120. So this volume will be 1120 inches cubed. And remember, one dimension would be inches. If we're doing area, 2 dimensions, it's inches squared. And as soon as we switch to volume, then it will be inches cubed, or centimeters cubed, or whatever. So that gives us an idea of how to calculate the volume of a box. Now let's take a look at another problem and say I now have that box, and let's refresh our memory on what that volume was, 1120 inches cubed. So how many 7 inch by 4 inch by 2 inch boxes will fit into the larger one? Will fit into the box from question 1. So now it doesn't matter what we're manufacturing. We've got a box that has 1120 inches cubed. And now we're wanting to put these smaller boxes. It doesn't matter what they contain. They could contain jewelry or anything that a manufacturer is going to ship. So it's important that we know how many of these boxes can actually fit into the bigger box. So let's find the volume of this smaller box, and we know it's 7 inches, should be inches, 7 inches by 4 inches by 2 inches. And so volume is equal to length times width times height, which is 7 times 4 times 2. 7 times 4 is 28, and 28 times 2, 2 times 8 is 16, 2 times 2 is 4, plus 1 is 5. So we get 56 inches cubed. And so now we need to find out how many of these smaller boxes will fit. And so we know that the total volume of our box is 1,120 or 1,120 cubic inches, and these smaller boxes are 56 cubic inches. So if we take the volume of the big box and divide it by the volume of the small box, that should equal the number of boxes that will fit. So I hope that makes sense to you. And so we have then that the number of boxes is equal to 1,120, remember? 1,120 divided by 56. And so now this will give us a good opportunity to do our long division here. And so we have 56 divided into 1,120, and 56 doesn't go into 1 or 11, but 56 does go into 112 two times. 2 times 56 is 112, and we're left with a 0 remainder. So we need to carry down here and add our placeholder up top, and we land up with 20 boxes. So 20 small boxes will fit inside that larger box that we calculated in the first example. Now, is it realistic that we're going to ship these boxes without some sort of padding on the inside of the shipping box? So now we're going to add a third part to this question, and we're going to take our original big box, and we found out that with no padding, how many boxes did we have? We had 20 boxes that would fit. And so now, what about if we put a 1-inch padding on the inside of every side of this box? And does that make sense? You know, you get boxes that are shipped with styrofoam around every side, right, to give it some padding. So let's remind ourselves of the dimensions here. We had 14 inches by 10 inches by 8 inches. And so if we take a look at putting a 1-inch padding, and that's around every surface, we'll put it around the top, on the underneath the top, and on the bottom. So when we look at this, does it make sense to you that our dimensions here are going to be sort of an inch shorter in every direction? So if we just look at the top, for instance, right? If we just look at the top, we're going to have a piece of styrofoam that goes, let's say, this way along the top. And because they're all 1 inch, and we're going to have 1 inch on the bottom if we look at the front row here, and if we look at the side, we're going to have exactly the same thing. So it should make sense to you that we're going to have to take apart or take away something from the length, the width, and the height. And let's just look at the height here, for instance. It was 8 inches. It was 8 inches, but does it make sense that if we have an inch at the top and an inch at the bottom, then our height now is going to be 6 inches? And now, if we put pieces of styrofoam here along the side and along this side, I'm now looking at the front view. Okay, this was the segment here. That would be now 6 inches. And our height, this is the segment that'll be 6 inches. And our width here is 10. So our segment in here now, you know what, I'll go over that in green. The green line here is going to be 8 inches because we had 10 inches for the width, but we had to subtract 2, so the width is now 8 inches. And similarly with the length, we're going to lose an inch at each side, so the length is now going to be 12 inches. And so now we need the volume of this box, and volume is equal to length times width times height, which is 12 times 8 times 6. And 12 times 8 times 6 works out to be 576 inches cubed. And so again, we can take the volume of the big box over the volume of the small box, and that should give us the number of boxes that can go in here now with the padding. And so we see we have 576 total, and we know again that taking from question 2, the volume of each of the small boxes in this question is 56 inches cubed, and so we have 576 inches cubed over, I've forgotten already, 56 inches cubed for the smaller boxes. And if we do the division here, we get 56 into 576, and 56 goes into 57 one time, and we're with one left over. So 57 minus 56 is 1, carry down the 16, and so here we have 56 is not going to go into 16, so we could put down our placeholder, but then you can see if we put down our placeholder, then we're going to be left with 10 point something boxes. And we don't even have to do the rest of this division because obviously we can't have part of a box, so the answer to this question is 10 boxes. So here we first calculated a volume, and then we thought, okay, if we're going to pack some stuff in that box, how many can we fit? And we calculated that we would be able to fit 20 boxes. But shipping boxes without any sort of padding in it is sort of unrealistic, so then we sort of added some padding to the inside of the box in the form of styrofoam or bubble wrap or whatever you have for interior wrapping. And we found out when we did that, we all of a sudden got half of the number of boxes. So that's pretty amazing that even if we put a 1-inch styrofoam layer on the inside of this whole box, it cuts the number of total boxes in half. So I hope that gives you a good idea of how to deal with volume of these sort of rectangular solids or boxes.